Hello again. Welcome to ATAR exam preparation. Today we're going to discuss question 19 on QCAA External Assessment 2022, Paper 1. Complex familiar question. This involved with simultaneous equation, similar triangle. So let's have a look at the question. So this is the theory of similar triangle. If the two triangles similar, their corresponding angles should be equal. Then the corresponding sides should be proportion. So the ratio are the same. So question said we got two parallel walls, A and B. So we got A, B, and CD parallel. So we know So AB is parallel to CD. There is so the both ACs are facing on north end. So this is a north. So if I'm using the north, that's north end. And fence B and C, we join BC. So let me using the another color. So let's say we have a green color. That's the fence BC. B joins C, 10 meters long. So AB is 20, so we got 20 meters for the AB. BC is 10. Now, if the question says if a new fence being built from A to P, so there's another fence built. Let's using orange. So another fence built from A to P. So P is a point. Didn't know where. So that we cross the BC at point O. So that's point O. All right, now we draw the diagram. We finish diagramming. Then we say if OB is X, so that's X. So we know the remaining OC is 10 minus. So 10 minus X is the OC. So we got those, and there's a degree, 30 degrees is the angle ABO. So now according to the parallel line, so we call angle AB. So angle B must be equal to angle C. So therefore the angle B is 30. So therefore the angle C is also 30. So those two angles are same. So those two angles are same angle. So then we also got the opposite angle here. So we got this angle opposite. Then the other parallel. So if you look at these two angles, so now this is an angle equals because of the. If you need a reason, we can say it's Z. All right, Z diagram. So we know parallel lines is crossing. So that's the corresponding angle is equal. So then also AB, same reason. So therefore angle A must be equal to angle OPC. So that's the same thing. So therefore we got the other angles here, 1 and 2. So if I use in the red color, this is angle 1, angle 2, little angle 2. So angle 1 is equal to angle 2. So now we got all those angles are equal. So then we can lead to triangle ABO, similar. So similar is using this notation, similar to angle triangle ABO is PCO. So these are the two triangles similar. So once they're similar triangles, so we can lead to the corresponding sides should be equal. So let's say the proportion should be the ratio between the corresponding sides should be equal. So let's say we call OCP, so which is over AB must be equal to OC over OB. So if I using CP is called Y, so if I'm using Y equal to CP, so therefore we have Y, AB we know is 20, OC is 10 minus X, then OB is X. So I'm going to rearrange that, so that will be Y equal to 20. All right, I'm going to put 10 times by X to the power -1 minus 1. So I'm going to using the index instead of using fraction. So this is my Y, so which is this side here. All right, now I'm going to use, the question says we want to be the total area of OBA plus OCP should be minimize the total area. So you need to find what is the X. So we need to determine the X equal to how long, so that total area, so we call area of triangle OBA plus triangle OCP to be minimum. So that's the question. All right, so let's find out triangle. Let's do one at a time. Triangle first, triangle ABO. So let's do that. We know triangle ABO is half of sine half AB times by BO times by sine the angle between the two sides, which is a 30 degree. So that's a sine rule. So we put a AB, which is 20, BO is X, and times by sine 30, which is 10 times by X times by half, because sine 30 is half. So the answer is 5X. So that's the first triangle. So let's do the second triangle, which is ABO. Now we go PCO is half of, so we call OC times by CP times by sine 30 degree. So we substitute. So OC is 10 minus X, and CP is Y. So we know Y is already found out was 20, 10 X to the power -1 minus 1. Then times by sine 30, which is half. Let me put a half. And we're going to cancel a few things. So 2, 4, that's cancel with 20, which is 5. All right, 10 minus X, 10X to the power -1 minus 1. So we're expanding brackets, so it'll be 5. So let's say 100 minus 10, -10 plus X. Expanding brackets, so it'll be 500 minus, that's 20, which is 20, which is 100, and plus 5X. All right, so those two. So if I'm going to put this together, so the total area, total triangle area equal to, for those two, triangle area of triangle ABO plus area of PCO, so which is 5X plus Sorry, this is, it should be x minus 1. I forgot that this one. Sorry, apologize for that. This is x negative to the power of negative 1 minus that. So the 5 expanding bracket should be here, should be 5x to the power of negative 1 minus 10, 100. So there'll be 500 times x to the power of negative 1, then plus 5x plus minus 100. All right, we simplify. I'm going to put this to first, plus 10 and minus 100. So that's my total area. So now we want to be total area to be minimized. So we differentiate. If I call this is the area, total area, we call total A. So total area in relation to x. So that's the total area. Differentiate that would be negative 500 x to the power of negative 2 plus 10. So we want to equal to 0. So we want to solve that. So be x squared equal to 50. So therefore, x is positive negative square root 50. So the answer is positive negative square root 5 over 2. However, x must be length positive. So therefore, my only x should be choose positive. Now, what's the unit? We using the meter. So let's put a meter. Now, but we don't know whether minimize or not. So we need to test this double derivative. So we double derivative of fx, which is negative become positive 1000 x to the power of negative 3. So we substitute the double derivative that value into that. So it'll be 1000 times by 5 square root 2 to the power of negative 3 will be positive. So therefore, the total area is minimized when x equal to 5 root 2 meters. So that's it. This is a optimization question, like a maximum minimum question, by using double derivative. So similar triangle as well. It's got geometry theory in it. So it's a pretty long solution, but involved with geometry and derivative and a double derivative. Thank you for watching. If you like the solution or video, please give us thumbs up and don't forget subscribe the channel so you will get the latest video. See you next time. Bye.